As we're waiting, let's just have a look at the last question that I think 1 minute before we left Jean made. So, in a new project automated process, named stakeholders are not known yet. The first time they are defined in a text document, but this information must be part of the KG. Right, so this is a typical case, right? So you have named stakeholders and they need to be put into the knowledge graph. So the question is, how many are these stakeholders? If these are, and also in what kind of text are they? Are they in a text that it's easy to extract them? So for instance, they are, I don't know, in one in each line or something like that. That's pretty easy. If you have a lot of stakeholders, named stakeholders that you need to populate your graph with, then and the structure is complex and it's not easy for someone to go over them, then you need an R solution. You need to build an entity solution to get them out of there. Okay, so to recap a bit, in the first part of this masterclass, we saw general things about knowledge graphs, development and mining, and we dived in a bit more deeply into the problem of finding entities, of discovering entities, so that then we can add them in the knowledge graph. Now, let's move to the problem of relation extraction. So let me share my screen. Okay, so a graph is not a graph if it doesn't have relations, right? So the question that we're going to tackle now is how can we identify in an automatic way relations between the terms and the entities that are that we have discovered from the previous step. So again, in the typical NLP literature, the task is defined as locating and classifying relations between entities mentioned in unstructured text into predefined relation categories. So for example, when we have the text, the sentence, Beijing formerly romanized as Peking, capital of the People's Republic of China, one relation that we may want to infer from there is that Beijing is the capital of China. Another relation that is not explicitly said, is not given in this example, but that would probably be useful, is that Beijing and Peking are synonyms, or at least, yeah, they can be considered as synonyms. So Peking is another way to refer to Beijing. So in the context of knowledge graph mining, the task changes a bit and becomes given a set of entities and a set of relations, get an appropriate corpus and find all the distinct pairs of entities if the relation is binary, or more if its cardinality is higher, that are related through this relation, right? So imagine that we have, from the previous step, from what we learned earlier, we have found all the entities that are persons, we have found all the entities that are companies, and now we want to find which persons, let's say, work for which companies. Let's say we want to populate the relation works for, right? So we want to find all the instances there. Now, again, this can be done with the one or more of the 6 approaches that we mentioned, right? So we can define hard-built patterns and rules for extraction. This is something that you can do it also with Spacie. I'm not going to cover it, but it's easy to, if you go in the documentation, there are nice tutorials about how you can define basic relation extraction patterns. We can also use supervised machine learning, where we take pieces of text, we annotate the relations within there, and then we use some model and we train some model to be able to find those. What I'm going to show tonight is a technique which is called transfer learning. And in particular, what we're going to do is that we're going to take a pre-trained language model that can determine the semantic similarity between terms and phrases, right? So language models are generally are models that are trained to predict the next word given a sequence. So it's about sequence mining. And what they do when they are trained in an unsupervised way is that they map particular words and sentences into vectors, into embeddings, as they are called, into real numbers. And when they have these embeddings, we can use them and we can get their similarity that hopefully denotes and reflects a semantic similarity between two words or two phrases or two sentences. So language modeling is the basic task on which these large language models are trained. What transfer learning does is that takes these pre-trained models and adapts them to a particular task. And in our case, what we're going to do is that we're going to fine-tune an existing language model so that it reflects a particular relation, not just semantic similarity relation. And how we're going to do that? By using positive and negative examples of that relation in slightly similar way that in the previous hour we gave additional examples to the space inert system for the entity type food, right? So we created a new entity. For that, we're going to use a library called SentenceBERT or sentence transformers. And what this library has done, what the creators have done is the following. They have taken, they have created an architecture where they take pairs of sentences, so sentence A, sentence B. They pass them through a BERT model, a BERT language model trained on, and take their embedding. So let's say that the embedding of sentence A is U and the embedding of sentence B is, sentence B is V. Then they consider their distance, and what they do is that they optimize, they train these models in order to, for sentences that have more close meaning, have a greater similarity, whereas sentences that have not so similar meaning, according to the definition that they are given from the data, have greater distance. So when this has been trained, then at inference time, we can give as input any two sentences and through the cosine similarity get a score that suggests if they are similar or not. So let me give you the link. Let me first of all unshare my screen for now. And let me give you the link to the second collab. Okay, so as opposed to Spacey, the SentenceBERT library is not by default in the Google Colab environment. So the first step that we need to do is install it. So you can do that via the command line or via Colab by executing this command. I have already installed in my machine, so I'm not going to repeat that, but if you want, just execute this. After we've done that, then what we need to do is just import the sentence transformer module. By having that, we can then load a pre-trained model. There are several ones. To be honest, I don't know which one is better or worse, let's say. So there are on the website, which by the way, I can show the website of the library. It's this one. It's called sbert.net. So you can visit it and have a closer look. They mentioned some differences between the pre-trained models. In this case, what I know is that this particular pre-trained model has been optimized for the task of natural language inference. What is natural language inference? Natural language inference is the task of getting as input two sentences and determining whether one sentence has equivalent meaning to the other, or its meaning is entailed by the other, or their meanings are opposite, contradict each other. So if you have the sentence, I don't know, Athens is the capital of Greece and Athens is not the capital of Greece, and then in a natural language inference task, these two sentences should be identified as contradicting. So by loading this model, sorry, I think I need to run it. My old machine has been reset. By the way, when you install this, make sure that you restart the runtime, because in order to take the difference. So let's wait a couple of seconds. So this, as I said, installs the library, the module. By the way, we were 27 people, so I think, Elias, if you want, we can switch to a chat view. I think it may be more interactive like this.
Yes, Panos, in what exact form would you like to do this? In a discussion audio only, audio and video?
Audio and video, I think, because we will do a lot of Q&A here. And
okay, give me just a moment, please.
And I'd like to see the faces of people.
But we will need the screen, right?
I need to give you the screen first, right? Okay, let's do it a bit later.
No. What's preferable for you? Will you need to share screen in the meanwhile?
Yeah.
Okay, let me just find a better way to accommodate this.
Okay. Okay, so we have installed this. I'm restarting the runtime.
So I think everybody can. I will start giving everyone audio and video access.
Okay. Okay, so now we have managed to import the sentence transformer, and now we are loading the model. So it's a big one, so it takes a while. It's done. Now, as soon as we have the model, we can define a basic function, a basic find similarity function that takes as parameters the model and two terms, term 1 and term 2. And the way to compute the similarity between the two terms is just by taking the embeddings of the first term, by using the model to encode the term with the parameter convert to tensor equals true, and the same for the embeddings of the second term, and then just calculate the cosine similarity between the two vectors, between the two embeddings, and then print the score. So by doing that, we can just start playing with the similarity between terms. So I have here some examples from professions. It's something that we saw also in ESCO and we saw in TextKernel. It's very common. So we see, for example, that according to this pre-trained model, software developers, software engineers have a similarity of 0.85, so they are quite near. database designer data architect 066, whereas welder and solderer just 042, although they are actually well, actually they are almost synonyms. Now, it is possible to work just with that in some cases. What do I mean? Even if you don't, depending on your domain and on the type of entities and the relations you have, it is possible that many of the relations that you target are included under the similarity one. Or vice versa, if it may happen that if two entities are not related via the target relation, they're not even related through the similarity. So this can be a fast way to exclude entities that do not have any relation whatsoever. It doesn't work always, but if it does, it can save you a lot of time from that you would spend trying to create the optimal relation extraction model. Especially if two terms have a really high similarity, like more than 90%, there is a strong indication that they're quite similar. And it may be that they are even synonyms. But of course, this is something that really needs to be you really need to evaluate for your case. Now, the find similarity finds just the similarity between two terms. Now, imagine that we have, I don't know, 50,000 entities in our knowledge graph, right? And we want to find all the potential relations between them. Then we would need to do a pairwise, to compute the similarity between all possible pairs, which there can be a lot, right? It's actually 50,000 square. Luckily for us, this particular library, SBERT, has an implementation which is called paraphrase mining that implements a more efficient algorithm with some heuristics that allows for a given set of terms to find the top similar pairs. So the way it works is that we get a list of terms as input, and we compute the paraphrases by running from the model the util.paraphrase mining, and then we can get the main score. So if I run this, I gave it as input data science, data engineering, welding, and soldering, and you can see that it gave me the most typical pairs. So data science and data engineer with a similarity of 0.57, welding and soldering with similarity of 0.36, etc. So semantically, from a functionality point of view, from a score point of view, the paraphrase mining and the find similarity are not so different, right? So they use exactly the same information. The only thing that changes between the paraphrase mining and the find similarity is what is the input and what is the efficiency by which all the pairs can be analyzed. Okay, any questions on this? Actually, we can also, Elias, we can close the poll, I think. I don't know if you can end poll. I will end it. Okay. So if someone has a question, please mute, or I don't know if Elias, if they can mute themselves. And show yourself.
I have given audio and video access to everybody. They can mute or unmute and take the floor.
Okay.
Panos, what about if I want to find, I don't know the list of possible phrases. Is there any way that there's a suggestion of phrases? So if I have just data engineer and I want to know other possible synonyms.
You mean if you have only the one entity, but not the others, right?
Yeah.
Okay. In that case, I mean, in general, you can do it. You can always define an extraction rule. It's possible, right? Not through this framework, but through a framework like Spacey, for instance. And I don't think it would work with BERT. I'm not completely sure. I know it could work with word embeddings and with word vectors, where for a given word you can find its top similar from whatever words it has learned. I'm not sure it is possible to do this via this framework, but I make a note and I will definitely research it for the future.
Perfect, thank you.
Any other question?
Panos, how do you validate that the similarity score embeddings are accurate?
Right. Great question. So, similarity is quite subjective, right? So, there are in the literature some benchmarks that the researchers use when they build these models. But ultimately, it depends on your case and on your relation, right? If the similarity reflects the semantics that you have in your mind. And I'm going to show in the next hour in the methodological discussion examples where semantic similarity, the definition can be quite vague and subjective and context dependent. Actually, I have a half chapter in my book about why semantic similarity is tricky. That, you know, it's quite easy to calculate it. There are many language models and word embeddings that give you some kind of similarity, but whether that similarity is the one you actually need for your application or for your domain remains to be validated. The way to validate it would be to have human judges, right? To really see if they agree on this or not.
Yeah, I mean, my domain is healthcare, and of course, the classic example would be something like cell, right? You could have a prison cell or a biological cell, or you could have a cold, right? You're sick, you have a virus. So when we say cold, we mean virus, but at the same time, you could be cold temperature-wise. Even though the semantic, I mean, if I run cold and cold, of course I get a similarity score of 99999 because the words are exactly the same. But the context or the semantic meaning is different. So I guess I'm wondering how, using this method, you can validate that the model is using the semantics that you think it should be using.
Right, I understand. So the one way to predict that is, I mean, the one thing is that you don't know. So now let me say it differently. These models, language models like BERT, utilize a lot the context. So if you just give it as input cell and something else, just the word cell, then it doesn't have any context to decide what is the meaning. If you give it a more complex sentence, right, the cell of the organization, I don't know, is found to be, I don't know, prone to this disease or something, just saying, then what these models promise is that the cell will be there in that context will be interpreted more correctly than if it was on its own. So usually the way to work with ambiguity is by giving more context.
Okay, I understand. Thank you.
Okay.
Actually, Panos, I've got a quick question, if I may. So I'm Bharat Sharma. I'm information architect for digital.nhs.uk, so I'm in healthcare.
Nice.
I'm wondering, actually, because my perspective is training off a website. So it's almost like, yes, you want to train on word embeddings, but also you want to consider that one section of our website is talking about a similar topic. And I'm thinking, how do I bring that into the training model so that when you're talking about a specific term, if those two terms are being used on similar areas of the website, that they have a stronger, relationship. If that makes sense, it's almost like, how can I influence the vectors to be closer because those words are found on the same part of a website, on the same section.
Right. I'm not right. I don't know very well how it works, but generally to influence the vectors, and this is something that we're going to see, I'm going to show an example of this. To influence the vectors, you need to actually, okay, when you have a trained model, either a language model, which is trained on a big corpus, right? Either word embeddings or language, it can be influenced in two ways. One is to train it again in your own corpus, which will be more specific to your domain, right? So instead of, for example, training it in news articles that can be about anything, you train it on to healthcare that mentioned it. That's one approach. The other approach would be to add some supervision and to give explicit examples of things that should be close.
Yes.
And things that should be afar, and adapt it and fine tune it. And this is what I'm going to show right now.
Yeah. So maybe we train like sections of the site together, content from a similar part of the site together.
Yeah.
And to do it, split it up.
Yeah. I don't know what section is a piece of text, probably. Yeah.
Yeah,
it's just if you have individual terms that in your case should be closer, then you need to somehow tell that to the system and take it in mind.
Yeah, it was either that or use the URL path almost as a word.
Yeah.
Because the URL path will be quite similar to another URL path because they're part of the same structure. So, one of our products.
I haven't worked with websites like this, but I understand what you're saying.
Yeah, this is the kind of things I'm thinking of, so I'm just making it complicated.
Okay,
Thank you.
So you're welcome. Okay, so let's see. So let me share my screen again. So let's say that, as I said, as people mentioned, we're not happy with these results, right? We're not happy with, before that. Let's say that we want to validate, as someone said, how this works for a particular case. So let's say that we want to apply this to find synonym terms, synonym occupations in this case, like in ESCO does. So I can already show you ESCO. ESCO is this one here, and it has occupation. So we can find, for example, the occupation data scientist. And it's what I mentioned in the beginning. This is the concept of data scientist, and these are its lexicalization. So all these terms, data scientist, data engineer, research data science, data expert, data research scientist, are considered to be belonging under the same group, assumed by ESCO experts to be identical, to have the same meaning. Now, let's not debate here if they are actually the same meaning, but let's assume that we want to see how well the SBERT model captures the thinking of the ESCO experts, right? So if we run, if we would run SBERT model to group the occupations of ESCO, would it come up with the same grouping, with the same synonym detection? So one way to do that, what I did actually this morning, is that I parsed the ESCO model. ESCO actually is in RDF, so I just downloaded the model and parsed it, and I created a data set, which you can see here. So it's a pretty simple data set. It has one term, another term, and a score of whether it's identical or not. So I took the terms that belong to the same entity and I gave them a score of 1, so that this should be identical, and terms that belong to a different entity have a score of 0, right? So, and in total, I have, I think here, some thousand of examples, 2,000 pairs. So, having that, I wrote some code here to read this file and split them, as I would do in a machine learning project, into a train set, a validation set, and a test set. So I just did a 60%, 20%, 20% split. So when we do this, we can take the test examples and evaluate the S-BERT, the system, with respect to how well the similarities that it gives correlate with what the ESCO people were thinking, let's say that. So we run this. Let's hope it runs. And it gives us a score of 0.75. So it's not the best correlation, it's not the worst. It's more than random correlation, but it is positive, right? It shows that the pre-trained model captures some of the similarity of the synonymy, if you like, that ESCO people had in mind when they were creating their model. Now, let's say that we're not happy with that, and we want to further fine-tune the model so that it reflects better this data set here. What we can do is that we can adapt it by using this data as training examples. So, the code to do that is here. So what we do is that we this uses a framework PyTorch. So we define some training parameters, we load the data, and we train it. Now, I'm not going to run it here because it takes, so with this amount of data, I think it took me around half an hour to do the training. But after the training, I saved the model. So when you also train it, the model will be saved. So then I can use it. So when we create the adapted model, what we can do is find the new similarities. I think I'm missing something. Wait. Yeah. Sorry. I need to load the model from the saved place. Sorry. I need to have this. Sorry, my model has been reset, so I'm not able to use it. Sorry for that. But the thing is that after you train it, you can run the model and then you can run the evaluator again. And when you manage to run it, you will see that there is in this score a slight improvement. So it goes around from 0.75, it goes around 0.78. So 3% increase. Now, it's not a lot, but it actually indicates, again, the direction, one direction that you could take in order to optimize the semantic similarity towards the direction, towards the semantics of your target relation. It won't work always. It might be that no matter how much data you give it, it's not going to improve, or even worse, it might overfit. So it may, depending on the quality of the data that you give it here, it may overfit, and then it doesn't generalize very well. So in new examples, it really gives bad results. But I invite you to play with this, and if you are able to, if you have your own data, try it and see what you get. That's it for this part. Is there any question?
Hey Panos, got a question.
Yes.
So first of all, thank you so much for this very lively topic. It's quite interesting. Did learn a lot today. Given that NLP is kind of like very, I just kind of like know it from a distance. I'm not even a beginner in that space. But one thing I would like to know or to understand, this is all good stuff. But so far, what we have learned is what sort of different packages, libraries, or different approaches that you can use to actually extract information out from the text. But do you intend to spend some time on how you actually embed this knowledge in the construction of your knowledge graph later on, how to actually use all that information?
You mean how
from the text? Yeah, I mean, because we have seen so many different examples that you can extract certain entities out from the text, but how you could use it while constructing your knowledge graph, or where you actually can use it.
So the idea, I don't have an implementation of that currently as an example, but I think your question is the following. So let's say that my starting point for the scenario that I have in mind is that I start with a very basic knowledge graph or ontology, if you like, that defines only basic entity types. Okay, so if we consider ESCO, we start with we open, I don't know if you use any ontology tool like Protégé or something, but
yeah,
right, use Protégé. Okay, so you start with Protégé, and you define a class called occupation, a class called skill, and a relation between professions and skill. Let's say that's the starting point, right?
Mm-hmm.
Then you need to populate this. So what you would do is you would take a corpus, you would go and select a corpus that hopefully contains the entities that you want, professions and skills. So let's say that you have CVs, and you would use one of these tools that we mentioned to build a system that will give you the entities, give you the terms that belong to this entity. So if you see it as a black box, let's say you create a skill entity extractor,
mm-hmm.
The system as a black box would get a corpus as input and a list of terms that are skills as output. When you have this output, what you can do is that you can write code to create instances in Protégé in OWL, if you like, or in RDF, and say, for example, that this term, I'm making it an individual, and this individual is RDF type of the concept of the class skill. It's as simple as that, as a first step.
Right, got it. So
right, and the same for professions. Then your next task would be to find, because you may have found duplicate entities because of synonymy. So you may have, for example, an abbreviation in its full version as distinct entities. You would need a synonym extraction system. One way to do it, again, would be to run what I just showed, SBERT, and, for example, say that, okay, assuming that you don't want to put any human in checking that, right? If you want to be fully automatic, what you can do is say, okay, if the similarities are no more than 95%, consider it synonym and add it and put these entities as one. That would be one option. Another option would be to use the extractor, take the most the pairs, the related pairs with that you have the highest confidence, and have a human check them and say if they're good or not. And again, when they have annotated them, add them in your knowledge base. So practically, you have your NLP systems on the one hand and your implementation of and representation of your knowledge graph here, right? What you need to build is a link, let's say, between some script, some code that takes the output of the NLP systems and adds them to as input to the knowledge graph database that you have. If that may be RDF, it may be Neo4j, it may be whatever. This is not so much algorithmic, it's more of an engineering problem.
Got it. Okay. So just one last question on that, so that I just want to make sure that I understood correctly. Yeah. So when you say, let's talk about the RD side of things, that you define your basic class, that you have a class called skills and you have a class that you define that as profession, right? Mm-hmm. So these are the two classes we're talking about, right? You're not talking about instantiation of those two classes as well, where, for example, for the skills that, I know Python, I know Java, I know all those things. Are you, when you say that, you need to define those classes, are you also talking about populating the instances for those classes, or you expect the instantiation of those classes by kind of running those NLP approaches on the corpus of data?
So in the class profession, its instances are individual professions, not professionals. So data scientist would be an instance of profession. Yeah. Python would be an instance of skill. Mm-hmm. Right? So in that case, the scenario would be an instantiation of the class, skill, and profession.
So it has to be there upfront.
No, what you need to have there before is the classes, not the instances.
Oh, right. Just the classes. Like when if you're talking about RDF ontology, all you need is just two classes and no instance data. And you're saying the instance data will be populated through those NLP approaches.
Now, it can be that you can consider also the scenario where you don't even have the classes. Yeah. Or you have some basic classes, but you need to also discover and mine the subclasses. So it may be that you have a class, let's say you have a class skill, and then in the text, you find the term soft skill. So soft skill would be a subclass of skill. Yeah. This is a different, it is also an NLP task you can consider, where you want to find the hyponym of the class to make it a subclass. I didn't explain it here. That one, I don't have an example for that, but it's also another NLP task for that. It's also a type of relation between two terms. Generally, in knowledge mining, we start from words and terms and phrases, and we map them to the conceptual space, where we have classes, individuals, relations. That's the challenge that we do.
Right. Okay. So this is the piece I think I would like to understand. So you have the skills class, and it's just a class on its own on the ontology side of things, and then you have a corpus. Do you think the spacey and those NLP things that we just learned today, they are smart enough to pick, let's say, if there's a thing called software programming, that they will pick it as a skill. If there's a mention of Java or if there's a mention of Python, they will pick it up automatically as a skill, and all we have to do is just map them together? Or do we need to do do we need to provide some training data first through space to those things to see that, if there's any mention of Java or Python, those things, then pick those terms as your instances of class.
Right. So what we saw here today is that spacey, as it is now, when you take it off the box, off the shelf, supports only 10 entity types. So it doesn't support skill. So if you just run space on a corpus, it will not tell you that Java is a skill. Yeah. So on its own, it only can tell you about persons, organizations, and the other things that we saw. If you want to make it be able to find skills, you have various options. One option is to write your own extraction rules, which it's cumbersome, it's manual, it's expensive. Another way would be to give it training data. So to take documents, texts, annotate them, and feed them, as we saw on the collab, and feed them and train the model, hoping that it will learn to identify skills or whatever entity you want.
Got it. Right. Okay. So there's kind of like a bit of a training that is required there. What we learned in the first session through Spacey, that you can actually either add new rules or you kind of like train it by kind of like giving a sample of data, and then you have to run your model on the whole corpus, and it will allow you to pick
on the whole corpus, on selected corpus, on individual sentences, but usually on the whole corpus, to find things that.
Got it. Okay, right. Okay, that makes sense. Now I actually kind of like I followed the whole journey how we actually bridge the gap between this NLP what we learned today.
No, it's really important that it's as clear as possible. Thank you for your question. Yeah.
Perfect. No, I appreciate that. Thank you, Panos.
Okay, if there's no other question, I think we will set it on 15 years. We have 10 minutes before, but if there's no other question, then I think we can have a 5-minute break and move on to the last part, the last session of this masterclass.
Okay, I'm pausing for 5 minutes.
Okay, thank you. Okay.
Panos, can
Yes.
you hear me?
Yes, hi, Johannes.
Thanks for the great talk so far. When discussing with my two student assistants who are listening in as well, we were wondering how many examples for training data you would need for a proper training with reasonable accuracy and not too many false positives and negatives, especially when thinking about that a knowledge graph usually has like many different entities, many different types of relations. So
Yeah.
essentially you would need a sufficient number of examples for each type or class, let's say group of relations. And even if that knowledge graph is relatively small, the numbers are escalating pretty quickly. And I guess you have quite some experience in like giving a rule of thumb estimate of how many examples we would need, right?
Well, yes and no. I mean, the actual number is something that I'm also trying to. The actual number, being able to find a ballpark about how much annotations you need, right? I guess you mean how much label data, right?
Yeah, the amount of annotated data, right?
Yeah. So I don't have a good answer on that, to be perfectly honest. But what I can say is that it doesn't. You need less annotated data and less data than if you cared about the NLP task itself. And it's related to what I said in one of my slides, that the goal when you analyze text to populate a knowledge graph is not to find all the entities that are mentioned in the texts or all the occurrences. You just want to find all the distinct entities. So for instance, if you have a particular entity type, so let's say companies. Companies may be expressed in text in various types of contexts and expressions. So a proper system that would be able to find all occurrences would need to have training data for all the types of contexts where these entities appear.
Exactly.
But for a knowledge graph, if you are able to isolate the data that have some of the context and focus on some particular context that it learns well, you're probably okay with that, because you will still discover the entities and you'll be able to put them in the knowledge graph. That's basically intuition. I don't have concrete numbers to show that. It's a nice research project, actually.
We're just doing that, or in the process of doing that. And also,
and it's also, sorry to interrupt you, whenever I talk with machine learning people, and I usually ask them, okay, is there a way, to predict the number of annotations, the number of labeled data that you will need for a given task? They say no. The only way to do it is, start small, train a model and see where it gets you if you need more data. So there are some techniques, I think, to see if you can improve further the accuracy of your model by adding more data, but they cannot really tell you a priori just from the definition of the skill of the entity or of the relation.
Yeah, but usually you can. I mean, I'm a economist with a specialization in statistics myself, and usually when doing classical statistical models, you do know the ballpark around which you should aim to get a proper results. So I'm confident that we can get that, but I just wanted to hear your opinion on that. Another thing would be the synonym detection, because I haven't been doing this before, and I thought you might weigh in your opinion on this approach, because I thought like a very naive approach might be to just take word embeddings, cluster them, or getting distances between words, and then identifying clusters and using or selecting the most relevant in terms of TF-IDF or similar measures term from a cluster of very similar words, and then like adding a few bells and whistles to then have an acceptable first shot at very similar words from a similar domain.
Yeah. So the difficulty in synonym detection. I can hear myself. I don't know why.
I'm hearing you perfectly well.
Okay. So the issue with synonym detection is let's say it's easy to find, relatively easy to find irrelevant words and exclude them. But when it comes to the details, to the subtleties, then it becomes a problem. So for instance, if you take, let's say you have the term software developer, a profession, and then you have junior software developer. The similarity is very high, but are they synonyms? For some context, for some situations, it's okay, you don't really care about the distinction. But if you care about really subtle distinctions, in terms of synonym, you are really strict on synonymy, then this method will not give you the full accuracy that you want.
Yeah, so this ties into another project of mine, which I will try to pursue somewhere in the future, which is rotating the embedding space of a like word2vec fast text or something similar to make the dimensions interpretable, to like putting a label on embedding dimensions, which would help to kind of identify what type of subtlety those two topics are different in.
And of course, word embeddings, the typical word embeddings and fast text usually do not support ambiguity. So if you will take only one sense per word, or at least it won't be, they are not usually able to find, if you have the word bank, you will not get distinct meanings. You will get one vector for that. So that's something to consider depending on your domain, how ambiguous it is.
Yeah, that's a great point, actually. Thank you.
And this is something that latest models, Elmo and BERT, try to some extent to tackle it. They're not always successful, but that's why if you saw when I showed the BERT, the SBERT architecture, it has in the slides you will see that there is something that's called pooling, and pooling is because for a given sentence, BERT doesn't give you one embedding; it gives you multiple based on the context that it has seen, and pooling actually averages everything into one. That's what it does. But it may be that the multiple ones can be useful for what you do. And yeah, and as Alejandro said, word embeddings do not consider word order, indeed. Okay. Okay, good. So let's move on. I really like the discussion so far. So let me share my screen. Okay, so let's continue with some high-level methodological aspects, and I think I will try to tie them up with all the questions that you have posed so far. So, I would like first, my book is about pitfalls and dilemmas, and some of the pitfalls that I mentioned in one of the chapters has to do about the way we go to acquire knowledge, both manually and automatically. But especially when we try to acquire knowledge, to mine knowledge automatically, we tend to do two errors, let's say, two mistakes. One is looking at the wrong place, and the other is using the wrong tools. So, I don't know if you know the joke that says that there is someone walks into a dark street and sees someone looking around a lamp. He goes and asks him, "Okay, what are you looking for?" "I'm asking my key. I'm looking for my keys." "Okay, did you lose them here?" "No, but here there is more light." So it's a similar situation with knowledge mining, right? So when we talk about data science and data mining in general, most of the scenarios start from the data. We have some data and we want to extract some knowledge out of them. That's okay. But when we talk about knowledge mining for knowledge graph extraction, it goes the other way around. We start from what we want to extract and then we select the data, not because, and the data that we need may not be the data we have. So it's important that we use the right data. So to give you an example from my company, one of the mining tasks that we want to do is to be able to find which skills are more in demand for a given profession, right? So candidates ask, okay, what skill do I need in order to find a job in that profession? Now, if we analyze this knowledge from CV data, the relation that we will get will not be accurate. Why? Because CVs reflect the supply side of skills in the labor market, right? The skills that are contained in a CV, in a data scientist CV, for example, indicate what skills the particular data scientist has, not what the industry wants. What the industry wants, right, what the employers want, what skills they want, are reflected better in the vacancies that they publish. So the risk of using the wrong data is wasting time, of course, and resources, and trying to find something that does not exist, but also adding inaccurate knowledge to your knowledge graph. And the reason for that is that we often don't specify and describe the target semantics accurately enough. And my favorite examples here are semantic related to synonymy. And this is related to the question that someone posed earlier about how we validate semantic relatedness. So many of you here are computer scientists, right? So if I ask you, is Prolog semantically related to Python? Now, some of you will say yes. Why? Because they are both, for example, programming languages. Indeed. But if we think that in the context of hiring, right, in the context of hiring, if someone is experienced in Prolog, and there is, so in his CV, he says that, I'm expert in Prolog, good. And we have a job vacancy that requires a Python programmer. Would you hire that person just based on that knowledge? Probably not. Why? Because Prolog and Python, they are both programming languages, so they are similar with respect to that aspect, but they are from a computing philosophy perspective are very different from programming paradigm, right? And that's subtle knowledge that it may not be reflected in a typical semantic similarity framework, because semantic relatedness ultimately is vague and context dependent, and the same applies for many other entity relation types. Synonym is another example, and it's a really painful example. In this table, you see synonyms as they are expressed, as they are defined in different ontologies and knowledge graphs. So in ESCO that I mentioned earlier, you have as synonyms of chief executive officer, the terms senior executive officer, chairman, CEO, managing director, and even president. And in WordNet, you have as synonym of chief executive officer the term chief operating officer. And most of us that work in corporations and companies, we know that these two professions are different, right? They do share similarities, but they cannot really be considered the same job. So why we define bad synonyms? Why we say that these are synonyms but when they are not? Usually we forget or ignore that synonym is a vague and context-dependent phenomenon. So we're pretty sure that just because these two terms seem to be used almost interchangeably in our context, in our scenario, then yeah, of course, they are synonyms. Another thing is that we mix synonym with hyponymy and semantic relatedness. So I've seen many examples where people will take two terms which have similarities, and are related, and they say, yeah, this consider them identical and put them under the same concept. It may also be that we are unaware of subtle but important differences in meaning for the particular domain or context. And sometimes we also need the term, but we don't want to create a new entity. I've seen that happening. So I had actually a request from a client saying that, my knowledge graph needs to have not more than 5,000 entities. And I told them, okay, but your terms, your domain has many more. Yeah, he said, put them as synonyms of existing entities. So we had to squeeze, let's say, terms that were not synonymous as labels and as lexicalizations of entities that were not synonymous. And the final thing is that we don't document biases, assumptions, and choices. So when I see this, I'm sure that people from that defined WordNet or that defined ESCO had reasons, some reasons at least, to put these as synonymous, and they may be perfectly fine reasons for whatever goal they had in mind. The thing is that if you go to ESCO right now and you check its documentation, there's nowhere described what is the rationale behind this kind of definition. It is assumed as a global truth that indeed an economics analyst and an interest analyst is the same thing. So the lesson here is to pick the right data, right? And it comes a bit as opposite to the big data, obsession that we had the last years. That we have big data, we're going to get meaning out of them definitely. At least for knowledge, when we want to build knowledge graphs, it's important to have the right data rather than big data. So it's important to start with the data to mine after we have clearly defined the semantics of our target elements, not the other way around. We don't start with the data and say, let's see what semantics we can get out of them. I mean, we can do that and we can apply things, but most likely we will get a generic knowledge graph with quality problems that may or may not be useful. It really depends on the application, so I'm not excluding it altogether. Another thing is to push for semantic clarity and identify bias and assumptions, right? So let's say that you work in a team, the team says, okay, your product one, your boss says, we want to create a relation between professional skills that is where the skill is important for the profession. You really have to push there. What do you mean importance? Can you give me some criteria? Can we formalize this criteria if possible? It may not be possible, but at least you will have tried, and definitely through this process you will have identified heuristics and additional criteria that will make your life easier. And in case that for your project, for the things that you want to put in your graph, you utilize existing external data, it's important that you scrutinize them, no matter how compatible they seem to be. Go a bit back, you saw that during the relation extraction, the relation mining session, right? I used ESCO to try to train SBERT to find synonyms. However, the definition of ESCO, the definition that that ESCO has for synonyms is not something that is not the same as the definition that we have a text kernel, for example, for synonyms for professions. So in that case, even though ESCO and the graph that we have at external seem very similar because they both have skills and they both have professions as concepts, they have really different criteria for defining synonymy, and therefore we cannot really reuse a text kernel, the ESCO concept, the ESCO graph as is, right? We really need to pick what we use from it. The other pitfall is about thinking that everything is a nail. I remember interviewing people from my team some years ago, and when the question of synonyms came, like, okay, how would you design an NLP system to mine synonyms? The immediate and automatic response was, we'll just take word2vec and you're done. I was like, are you sure? I mean, as the discussion with Johannes just showed, this kind of embeddings and models, etc., can be really, really useful to start you with, right? But they are not enough. It's not that just because it's there, it always will solve your problem. It's a good thing to start, yes, but to expect that they will solve your problem magically, it's at least naive, right? Of course, in some cases, it's also the fault of the tools themselves. Many of the tools market themselves, especially commercial tools, market themselves as we can do everything, or at least we can do most of the things. But this is obviously often not the case, and I will show a concrete example in a few slides. So, something that, apart from the algorithms and the techniques that we discussed in this masterclass, a takeaway that I want you to have is how it's like, let's say, a way of thinking and a methodology of scrutinizing knowledge mining tools before you buy them. When by buy them, I mean you may need to pay money, but you also may just want to adopt a particular free system. You still pay it in the sense that you have to, in many cases, to invest time on it, right? Time and resources. So the first question to ask is, what extraction task and semantics does the tool support exactly? And I say exactly because, as we'll see, the devil is in the details here. The second is, does the tool deliver the semantics and the quality it promises, right? We saw, for instance, with Spacey that, okay, it manages to find persons, but when it comes to products, it had a problem, right? It mistook many products for organizations. So it doesn't have the same quality across all entity types, right? So even if you take an average, it still doesn't give you the whole picture. Third, does the tool have any systematic errors or biases? It's okay if a tool makes errors. The question is whether these errors are systematic and indicate some kind of flaw or bias or assumption that they may be, right? A fourth question is, what effectiveness range can I expect from the tool and under what conditions? So in academia, we develop a method, we write, we experiment in 1 or 2 evaluation data sets, and we report some scores. That's fine. But really what's important for an application in the industry is to know what can I expect from the tool. So if you tell me that, okay, you have a tool that will give me an entity extraction accuracy between, 70 and 90% only, and that will happen if the type of text are, for example, news, I'm fine with that. But if you don't tell me that, and just because you have tested it in news, when I try to test it to run it in another domain or in another type of text, it fails miserably, and I'm surprised by that, I have a problem, right? Obviously. A fifth question is, what are the ingredients and recipes I need in order to use the tool, right? We saw, for example, that with Spacey that, okay, there is the basic recipe, just take the existing system and run it, but it also allows you to do more complex stuff, writing, customizing your own extractors, writing rules, etc. So a tool that has a very good documentation of these things is really important, even if it's not the best in some kind of benchmarking, right? As opposed to something that is less predictable. And finally, how can we troubleshoot and optimize the tool's performance, right? So we saw again with Spacey and also with SBERT that, okay, we can run the baseline version. It doesn't work that well. Okay, That's fine. What can we do further, right? Should we add more data? Can we do that, right? Should we write rules? Should we maybe tweak some parameters, and how, right? This should be guided in a way. And to give you an example about the exact task semantics, I will describe some evaluation that I did as part of my work some months ago, where I had the opportunity to do an evaluation for my company of DiffBot's natural language API. So I don't know how many of you know DiffBot. DiffBot is a company that has a knowledge graph, develops a knowledge graph fully automatically by crawling the web. And part of its offering is an NLP API, a natural language API, that, given a text, builds a knowledge graph, right? So you see here that it gives the biography of actually its founder, Mike Tang, right? Where he studied, what's his current role, etc. And when you run this, it gives you a knowledge graph. So it says, for example, that one of the positions he has held is a founder, that he has worked in eBay, and that he has studied at Berkeley, which seems impressive, right? And it is impressive. And when I tried to do that, I started playing with some examples, and especially with Game of Thrones, because they mentioned that they analyzed the Game of Thrones anthology and they built a knowledge graph out of it. So what I found was, one systematic problem that I found was that their natural language API was not able to find synonyms, even in cases like this. So I don't know if you are familiar with Game of Thrones, but there is a character called Peter Baelish, who is also known as Littlefinger. So when I gave this input, Lord Peter Baelish, also known as Littlefinger, was the master of coin on the Small Council. Not only the system could not find that Littlefinger and Peter Baelish were the same person, but also it modeled the relation as sibling. And actually,
Hello, can you hear me? Did we lose Panos?
Seems so.
Looks like he dropped. I think he dropped.
Yeah, let's give him a minute or two. Let's treat this as an informal break, and I think he will be back with us. Sorry for that noise. That was my cats. Hello, Panos. From what I understand, you're trying to reconnect. Hope this will go smoothly. We're waiting for you.
Okay?
Great. Yeah.
Okay. So, okay. So, the ISE would give you things like if you said, let's say that imagine a text where you have an appraisal of an employer saying John is a skilled communicator and an achiever. It would model achiever as professions, as positions held actually, that John had a position held communicator and a position held achiever, right? And yeah, I can also talk about negation, but yeah, negation is generally a big problem. And it's okay if you are not able to detect it. The thing is, you don't want false positives out of this, right? So I have here the example here. For example, Einstein was not born in the United States, and he has never lived in New York. That's an example, and it gave me the exact opposite facts, right? Which means that in theory, someone could, in that way, would be able to infuse wrong knowledge into a knowledge graph. So imagine that in the context of disinformation, etc. It's not an easy task. I'm not saying it's an easy task, right? But it's important that it's an important thing to consider, especially from a safety perspective, let's say. And another nice example, the insensitivity to modal verbs. So one of the relations that the API supports is acquisition between companies, right? So when you monitor the news, you want to know that a particular company acquired another. So what I did there, I played a bit with the modality of the verb. So instead of saying, for example, PayPal acquired Payday, I said might acquire Payday or should acquire Payday, which from a semantic point of view means that the relation acquired doesn't hold, right? So might acquire in the future, it doesn't mean that it already acquired. So the result is wrong completely, right? So again, this seems to be a systematic issue. And again, this is just an example, right? I can take, and believe me, if you consider many existing tools out there, including text scanners to some extent, right? You will see some systematic errors. And our goal is, of course, to try to find them, to try to proactively find them as much as possible, right? It's a hard task. But it's important that we know as much as possible what our systems can and cannot do and under what circumstances we should be able to deploy them. Okay, wrapping up. I think that, again, from a methodological perspective, what I'd like you to keep in mind is that the steps to build an NLP solution for an knowledge graph would start from first understanding the task and semantics. Task means, what is the task? Do we want to detect entities? Do we want to detect relations? Do we want to detect relations between unknown entities or known entities? Things like that. And then it's semantics. Okay, the relation is named is essential of between professions and skills. What exactly does it mean, right? When it is true and when it is not. Then we can formulate the task, and third, we can create a ground truth based on the task semantics. Ground truth would mean that we need to have usually positive and negative examples of when something is true or false, right? Something that currently knowledge graphs don't really support is degrees of truth, right? Most of the knowledge graphs will say if something is true or it's not. It will not say it's true to some degree, or they won't really say that something is true in a context, in one context, and false in another context. So it's important to take the exercise and try to create a ground truth. Take some examples of facts and assertions that you want to have in your knowledge graph, and which should be true and which should not. This exercise, if you do it correctly, will not only will show you limitations in your definition of the semantics of the elements that you want to mine, right? And if you do it correctly, it will also help you find, go to the next step, which is to pick the data that you need, right? So it's about, the fourth step is about picking or building, of course, the data and methods that match the task and semantics, right? If you want more data. And of course, you need to evaluate. And in evaluation, for me, it's not enough to just run and get a score like the one I showed earlier that, for example, the S-BERT would have a correlation of 0.75. That doesn't say much. Really, you need to dive deeper and say, okay, this seems to be the accuracy, nice. This seems to be the recall, nice. But also, this seems to be a systematic error. And the systematic errors usually come from qualitative assessments like the one I showed. And also, the mindset should be, to some extent, adversarial. So, in a sense, let's try to break the system. More very similar to how in network security and information technology security, you have testing by trying to have what's called penetration testing. You try to invade the system to check that to ensure that its controls and its defenses are can hold. So imagine a similar mindset for NLP systems. If I try to attack the system, let's say, and make it give me bad information, wrong information, right? That I can either weaponize or not, doesn't really matter, right? Can I achieve that? If I can achieve that, then my system is really fragile. It's not robust at all. So I'm not going to repeat. These are the questions so if you are on the user side and you are evaluating a knowledge mining tool, please ask yourself these questions. And if you're on the other side where you develop a tool for knowledge graph mining, then ask the following yourselves. Does my tool support all the tasks required for building a knowledge graph? It's okay if it doesn't, but don't advertise it don't advertise it as a system that just will build your knowledge graph and you're done, right? You can say that, okay, it supports this task and under these circumstances. Right. So thank you very much for listening to me. It's been almost 4 hours. So you can see my email, my web, you can follow me on Twitter, LinkedIn. I'm also available. If you get the chance to read my book and you have feedback, positive or negative, doesn't matter. I would really enjoy listening to it, right, or learning about it. As I said, the material, the slides, I'm going to give them to Elias and share it with you. The links to the collab, to the 2 collabs, I think you already have them. I will leave them there, but please make sure that you make your own copy today or tomorrow, but anyway, the next days anyway, doesn't matter. And yeah, that's it. We have a lot of time for questions.
Hey, Panos. Quick question here. It's Aftabir again. So just to confirm, reiterating the question that I asked at the beginning of the session about, we talked about ontology with 2 simple classes, skills and profession, and how we can use NLP to populate our knowledge graph. So I was actually pondering about that solution that we discussed for the last half an hour. So it could be that, because me at a very early stage of this whole NLP stuff, so that's when I'm maybe lost somewhere. So that's why I need your help. So I got 2 questions here. And please do correct me if I'm wrong with my assumptions or if I'm off track. So let's say we define the class that there's a skill class and there's a profession. And then you have a text corpus on the other side. Now, obviously, Spacey out of the box doesn't know what skills or profession means, which means you need to actually provide some training data to it, or you really need to write extraction rules, right?
Yeah.
So so that's my first question. If we are to do that, which means then I need to know what are the skills that I need to extract from a corpus of data. For example, that in the skills I need to have the Java, the Python, C++, C#, .NET, all those things. So I need to know my domain knowledge up front, and then I need to actually feed all that through some training data, all that things into things. Right. Okay.
So you don't. That's the thing. You don't need to know them beforehand. What you would do is you would take a sample of your corpus.
Mm-hmm.
I don't know. Let's say you have CVs, right? you would take 100 CVs, and you would have people, annotators, right? Annotate in the text the mentions of skills. What you need to have is a definition of skill, a good definition of skill. What is a skill and what is not? Because you cannot have already a list. So you cannot say to the annotator, if you see Java, it's yes. If you see, I don't know, Python, it's not. You have to tell them a definition, a working definition of skill. A skill is something, for example, that someone knows for a job. Just saying, right? And this is actually the job of the knowledge engineer. And it's part, if you like, it's part of the definition of the class. When any class in an ontology, it's very important that you define its membership criteria. What entity, what are the criteria?
Panos, it's best that you disable your video because I think you have some problems with your connection. Let's just give Panos a moment to reconnect.
Hi, I'm back. Can you hear me?
Yep. Welcome back, Panos.
Okay, sorry. There is connection problem. Okay, so
Panos,
yeah.
Would you like to disable your video and continue audio
Yeah,
only?
yeah. Okay.
So
Okay, so
stable.
I was saying
Great.
after that exactly the difficulty and the challenge from the knowledge engineering side, right, is semantically and conceptually to define what the classes and the relations, your schema. So it's not enough to give it a name. You really need to give the membership criteria. And then this criteria will guide your annotators that will train the data and the evaluators of any model that gives you. Because otherwise, you're blind. You don't know if you get accurate knowledge or not.
Right. So can you expand a little bit with one example? How would you actually annotate your data? So I'm just picking one of the sentences that you had in your in one of your Jupyter notebooks. So where it says Steve Jobs would never drive a Mercedes. So initially we saw that it comes up as the Mercedes came up as an org, and then we trained it that no, Mercedes should be treated as a product, right? So. And then when we retrained this model and we rerun this sentence, it picked Mercedes as a product rather than an organization.
Yeah.
Now the question I have is, let's say now we have actually trained the model, the Spacey model, with Mercedes as an example. Can we just replace Mercedes with BMW and Spacey will pick BMW as a product instead of organization?
Yeah.
Or do we have to do it the same thing again?
Right. So the idea of machine learning is that hopefully it doesn't, when you give it an example where Mercedes is a product, it doesn't memorize the word Mercedes, but it learns the context. It learns other things. To the extent to which it learns the patterns or memorizes is something to be evaluated. And it has to do with the quality both of the data, but mostly of the algorithm itself. And one example of things that indicate memorization to some extent is that in some tools, you give it a sentence as when you test it, it says, for example, John, I don't know, is an expert in ontologies. It gives you perfectly the meaning. And when you say, Panos is expert in ontologies, it doesn't know what Panos is. So even though you have trained it with that pattern, it seems that it doesn't recognize. This is the general problem also with the fact that machine learning systems are a bit opaque, are not so transparent. You don't know you don't have explicit rules. So the rules that are learned are most of the times unknown. There are techniques to try to identify what it has learned in some cases. With deep learning, it's even worse. But you don't know. You hope that by giving it enough examples with different, it will generalize to identify unknown ones.
Got it. Right. So it's mainly about kind of like, you provide the same information but through different patterns, and then somehow these models will actually pick it.
Yeah.
When you actually
the power of machine learning is supposed to be the ability to generalize and to find the patterns that can be hard to define in a human way, right? To define it explicitly.
Right. Got it. Thank you.
Do you have some tips with handling this similarity score for synonyms? Because the score is not yet kind of a classification. So we need still a threshold to say, okay, this is a synonym or not. Yeah.
The tip is don't try to put a threshold. One practice, let's assume that one practice that we do, at least in my company, is that we use a ranking approach. So every time we have a new term and we want to find its synonyms in the ontology, because in an operational, let's say in our everyday work, right, we have already a knowledge graph and we get new things to put in there. And one task is to see where to position the new term. Is it already a synonym of an existing concept and therefore it should become a label of that, or it should become its own concept? So what we do there, because it's really hard to find a single threshold and to trust it automatically, for this term, we use such a model. We generate the top 10 similar / synonymous, candidate synonymous skills or professions, and then we have a human select the correct one. So it's not fully automatic, but it's better than if a human needed for a given term to select out of 20,000 candidate entities. So we reduce the number of candidates from 20,000 to 10. And I think in our case, it works with around 80% accuracy. So it saves time.
Thank you. Very good tip.
Panos, could you tell us a little bit about your work at TextKernel? Like what type of research you're doing? What's your technology stack? I'd really be interested in that, like to get a view from a different company, because I guess many of us, at least me, don't know anything but their own company. And I usually try to connect to researchers at university, but that's always a biased picture you get. And I'd like to get some input to
Okay.
Just
So
challenge my own views.
Yes. So we have 3 main products, let's say, which are interrelated to some extent. One product is called Extractor, and what we do is we get as input CVs or jobs, or vacancies, I mean, and we try to extract information from there. So if I take your CV, I will identify your name, the system will identify your name, it will identify where you were born, if you have this information, which positions have you held, how much time you spend in each position, all these things. And we will do the same for vacancies. The same for vacancies, we'll find what is the profession that it requires, the job title, what is maybe the location, right? The salary if it's there, and the required skills. Now, this kind of extraction happens in a hybrid way. Some information, like for example your name, it comes from a machine learning model, a custom entity recognition model that we have built, because it's impossible to have all the list of names, right? The same applies for addresses and locations. Other knowledge, like the skills or the professions, come from our knowledge graph. So there's no machine learning there. What we do is that we have knowledge in the knowledge graph, and we look for this knowledge in your CV. This allows us also to find synonyms. So if, for example, in one position you are saying you were junior software engineer, and in the other senior software engineer, and we believe it's more or less the same position, we would have it as a single profession. 2 job positions, but 1 profession, right? And the same could apply for skills. So we use our knowledge graph for NLP. And as I said, my team is responsible for building the knowledge graph and maintaining it. So what we do is that we store, technology-wise, our knowledge graph is, we don't use RDF, we use Neo4j. And we represent it by means of, as a property graph. We have built an editor on top that allows us to quickly do changes without knowing, because we have a dedicated data and quality team that maintains it, so they can easily create, edit, errors or add small pieces of knowledge. And then we do a lot of mining projects, so enrichment projects, depending on what we see as quality problems that we may have. And we also have algorithms on top of the knowledge graph that try to predict, to do, let's say, proactive maintenance. Because we know that, exactly because we do this in a semi-automatic way, we have flaws, right? We have low accuracy in some domains or in some languages. By the way, I forgot to mention, our knowledge graph supports 6 languages, and generally our parsing supports 17 languages. So we're able to extract information from CVs and job vacancies in 17 languages. Yeah, so we do a lot of mining projects for the knowledge graph, and yeah, we try to find as much as possible the best way to accelerate things. But so far, what I can say is that it's impossible to fully trust the automatic methods, right?
Yeah, that's
at least for our cases.
That's what you always have to fear.
And it's one reason for that is also because the recruitment domain is something that requires transparency. So imagine that, because we also I forgot to say that one of our products is about matchmaking, right? So we have a system that you can upload your CV and give you the most relevant vacancies. And vice versa, you can upload the vacancy and give you the most relevant CVs. Now, imagine these are things you can get sued, right? If someone complains why their CV doesn't rank very well. So you need to be transparent with respect to how your system works.
Yeah, absolutely. May I ask how many people are working in your core team? Like how much manpower or like working hours a year does it take to actually maintain such a thing? Because we are in a very small team, and I mean, the task is very exciting, but I fear very much that we have been handed a task that we cannot accomplish with 3 to 4 people.
Yeah, right. So in maintenance mode, so right, we have a team of 5 people that are dedicated to the quality of the data. So they get support. They work, let's say, as a support desk to some extent. And then for mining, we have small projects, and we try as much as possible all these years to build recurring processes and some kind of infrastructure that allows us to do efficient, fast mining. Actually.
No, that's
We
are
are lucky. We are lucky that we have a lot of data, because one of the things that we do, not so much with CVs, is we crawl the web for vacancies. It's one of our products called JobFeed. It's also about trying to find analytics about the labor market. So we have literally millions of vacancies across countries and across languages.
Yeah, we're working with ratings, so that's a very different domain, but we've got millions of data points. So data is not our problem, but the doability and will be. So thank you very much for those insights.
So
you're welcome. Yep.
Panos, quick question. I was really kind of looking forward to that. You will mention the ontology or the RD side of things, given that you're the head of ontology at text kernel. So are you not using any sort of a ontology in this whole piece, or
what is your definition of ontology?
I mean, usually, when you hear the term ontology, you see, okay, there's some sort of semantics or RDS side of things is happening under the.
No, there's no RDS. So that's the thing, right? The definition of ontology that I use is a shared conceptualization. So as long as I define concepts that are shared across the company and across its clients, for me it's an ontology. It doesn't have, for example, RDF type, but it has a relation instance of. It has another name. It doesn't have the standard RDF name, but it has semantics. Something to consider here is that we don't care, and I'm not saying that in a dismissive way, right? But it's not our goal with our ontology to be interoperable with external systems. We built our knowledge graph purely for the analysis of, to power our products and our services. We are not trying to solve the problem of semantic interoperability across systems. In that case, if we had let's say if we were collaborating with industries that would work with RDF, etc., we could work with that. I don't have anything against RDF, and actually it's using property graphs, it's something that I inherited when I joined the company. Right, so I'm not.
I get that, but you don't necessarily need to collaborate across industry, and only then you want to adopt the RDF standards, right? You can still use, or what are your views on that? If, for example, in this case, text kernel, which is kind of an internal solution just for that particular enterprise, you think a property graph with Neo4j on its own is sufficient enough, or you think yes, one could build something similar? But harnessing the power of RDF with reasoning and inferencing side of things. Given that you mentioned about ESCO as a taxonomy, as an ontology, where you spend a lot of money, and I'm hoping that you might be using certain concepts from that particular domain as well, right? But may have converted into your own schema, given that you're using.
We have mappings to ESCO, but let me also tell you that ESCO doesn't do any reasoning, and I really had maybe. I understand the power of reasoning that you say, but also most of the reasoning that we need especially for our search and match, is inductive reasoning rather than deductive one. So yes, you can do reasoning with the typical subclass reasoning or actions, but that would happen. But I would say that our requirements for representation are simpler. Maybe later we might want to revert to that. You also have to consider the cost of switching, right?
Yeah.
Because again, I could make the case for reasoning, as you say, but if now we want to switch to RDF, we need to buy a new editor from some company, whereas now we have our own internal, right? That costs us nothing. And the other big challenge in this case is to try to convince your engineers to switch to RDF, right? Because yes, conceptually and semantically, what RDF gives you is some predefined semantics. I agree on that. That make life easier a bit of your work as an ontologist. But this is for the conceptual level. For the actual engineering level, the data engineering level, I'm not an expert. I think there are discussions in this conference about this, about graph databases, which is best, which is most more scalable, etc. I leave it up to them. I don't have. Yeah.
No, I understand that. So you're spot on. And
but yeah, something that I don't like, and it's not your fault or something, is the hijacking of the term semantics and conceptual, etc., from the semantic web community. Before the semantic, right now, and this is something that I tried as much as possible. I don't know if I have achieved it a lot. Something that I tried in my book is to reconcile the terminology that different communities use. And you will see in the very second chapter that I mentioned 3 communities at least. The linguists, so WordNet, for example. See, what are scene sets? Scene sets are concepts, right? In a sense. But they use the terminology, they're called scene sets and senses, etc. Then you have the traditional taxonomists with some ISO standards, right? Where the broader narrow relationship hides in there the semantics of the part of, the instance of, and the subclass of. And you have the semantic web people, and you have the data modelers that come from the ER modeling and the relationship, warehousing, etc. Actually, last week I was talking to that conference, right? And this confusion with terminology leads to funny things, like you see ontologies with thousands of classes, but they're not really classes, all of them. Just because they think that the hierarchy in an ontology or in a knowledge graph should only be in the form of classes. Something that I think Protégé has created for them.
Yeah.
So yeah, it's not. It's we need to live all together.
Absolutely. No, I really appreciate your insights on that. I know kind of like you come from, if I'm not mistaken, or what I know since the beginning. I mean, because we know each other for quite some time, that you come from the semantic space, right?
Yeah, I come from the semantic community. Yes. Yeah. That's how I started. Yeah, my first conference was the semantic web conference, actually.
Good. No, it's really good to hear from you, from your perspective, what works and what doesn't work. And obviously, you're spot on that. It all depends on the use case or the requirements at hand. Yeah,
and also my criticism to the semantic web community is that they consider, at least that's the feeling I get, is that they consider the definition of RDF and all enough to, let's say, guarantee correct semantics. The thing is that all the elements, and the main examples I give in my book, is how the formal semantics of RDF are misused. Yes, you have the RDF subclass, but if you use it wrongly, what's good about it? You get, actually, there are examples where the inferences you make, right, the reasoning you make, may make a small error. So one direct assertion may result into thousands of wrong indirect assertions.
Yeah.
In a similar way that machine learning can propagate an error, right?
That's true. Yeah.
It's not an easy problem.
That's why we are here.
That's why we're here. Yeah.
And all of us.
Okay. Any more questions? Okay, I think then we can call it a day or a night, depending on your time zone. Thank you very much, all of you. I hope you learned things. I learned things from you as well. So I hope to see you somewhere in the future.